Today we compare two ways to instruct production AI agents. Natural language Agentforce topics, where an LLM interprets your instructions, versus Salesforce Agent Script, the code-based language Salesforce open-sourced at TEDx 2026 on github.com/salesforce/agentscript. Natural language prompts often skip steps or transition early. So Agent Script moves load-bearing control flow into a testable, auditable specification decoupled from the runtime. In the next few minutes, we cover what each is, how it works, why it matters, and how to apply it. Let's start with quick, precise definitions of each. Here is each one defined in plain language, plus where they overlap and diverge. Agentforce topics let us write plain language instructions that the LLM interprets each conversation. That flexibility handles open-ended dialogue well. But Salesforce notes the model can skip steps or transition prematurely because the prompt is assembled and reasoned over at runtime. Agent Script is Salesforce's agent definition language, open-sourced at TEDx 2026 with grammar, parser, and compiler on GitHub. It defines an agent in one file with state, execution flow, transitions, and deterministic hooks, all strongly typed for coding agents to edit. Agent Script is not interpreted at conversation time. Per Salesforce, the compiler emits an executable specification, a graph of nodes with fixed topology, known state transitions, and explicit tool wiring, decoupling execution from the LLM's probabilistic reasoning. Inside one file, the pipe character separates deterministic logic instructions, conditions, actions, and variables from natural language prompt instructions passed to the LLM. Builders pin load-bearing steps deterministically while letting the agent reason through the rest. Now, let us turn the comparison into actual decision rules. These are the four scenarios that cover most real-world choices. When a step must run before another, like verifying a customer before proceeding, natural language prompts can't guarantee it. Agent Script enforces these gates in code, so the order holds even as underlying models change over time. Natural language topics still fit open-ended tasks where flexibility beats rigidity. Agent Script keeps prompt instructions in the same file, so we apply deterministic control only per decision that is load-bearing, not across the entire agent. Because Agent Script is a code-based specification, it is testable and auditable, decoupled from runtime. Salesforce's goal is consistent, repeatable outcomes that stay stable as models evolve, instead of behavior drifting with each model update. This mirrors a wider 2026 enterprise pattern. AWS Bedrock Agent Core policy, now generally available, uses Cedar for deterministic evaluation with no LLM interpretation and enforcement, separating governance from probabilistic reasoning, reportedly alongside efforts like Google Model Armor. Let us consolidate the comparison into the points that actually drive your decision. Salesforce open-sourced Agent Script at TEDx 2026, publishing the specification, grammar, parser, and compiler at github.com/salesforce/agentscript to make deterministic agent orchestration testable and auditable. The core reason for Agent Script: natural language instructions frequently fail to enforce strict step-by-step logic and verification gates, leading to skipped steps and premature transitions in production agents. Agent Script sets control per decision. The pipe character splits deterministic logic from prompt text, so builders pin load-bearing steps deterministically while leaving open-ended reasoning to the LLM in the same file. Agent Script reflects a 2026 enterprise pattern. AWS Agent Core policy with Cedar applies the same separation of deterministic governance from probabilistic reasoning, keeping critical logic verifiable independent of the model. If your agents skip verification steps or drift after a model upgrade, weigh natural language topics against code-based control like Salesforce Agent Script or AWS Agent Core policy. Pin the load-bearing logic and let the model reason through the rest. For more information, visit Standarity.com. See you in the next video.